So we will try to define more things. I already mentioned natural climate variability and man-made climate variability, or human impact on climate change, when we looked at carbon dioxide and temperature change. So we'll revisit this concept several times because it's very important to always understand what is changing anyways because of natural factors and what is changing because of human beings. But it's more complicated because we have to also understand how human beings are modifying the natural variability. Right? We are not only causing new changes, but we are also modulating how natural variability happens. Why natural variability happens, of course, is because sun's radiation is coming, there is seasonal cycle, there is the diurnal cycle. Sun goes up, sun goes down, daytime warming, nighttime no warming or cooling, and so on, right? So on the long time scale, there are other factors that come in other than seasonal migration of the sun and sunrise and sunset. We already talked a little bit about the orbital forcing. So let's look at, and we talked about how some of the past climate change records are obtained, what we call paleoproxies. So we don't necessarily directly measure past temperatures, but we find evidence of the change, and we can look at the relative change with respect to some baseline. So we take a modern temperature record that we have, we know very well, we trust very well, accurate, reproducible, precise, and so on. And we look at whether the past climate was warmer than present or cooler than present, right? So here is a record constructed by various different methods, various different proxy sites around the world and so on, but it's the best scientific reconstruction. Goes back to 65 million years ago. You can look at the geologic periods above: Paleocene, Eocene, Oligocene, Miocene, and Pliocene and Pleistocene. We are right now in the Pleistocene. Holocene is come to an end. We are actually what is now defined as the Anthropocene, the age dominated by human beings. These are not names that can be just given when we want. We have to show that there is a geologic change that can be detected to change the name of the change over from the Holocene into the Anthropocene. It's a big scientific process. Okay. Nonetheless, here we are. Looking back when the dinosaurs were just getting extinct because of the meteorite strike and the following processes of whether it's disease or climate change or dust clouds that made it impossible to grow vegetation and so on and so forth. The first thing you notice is this time scale, as we said, in paleoclimate always goes backward. So we are going from 65 million years ago coming forward to the present. So you can see in the present the change with respect to some reference period. Let's say typically one that is used is 1961 to 1990 as the mean reference line. We are in some range of temperature. Here is benthic delta O18, which I will explain how that works. But essentially you can look at it this way. The polar oceans were up to 12 degrees warmer than present. The polar oceans were up to 12 degrees warmer than present, which means there was no Arctic ice, there was no Antarctic glacier, no Greenland glacier, and so on, right? So 12 degrees warmer, that's a lot warmer. But we know that dinosaurs and mammoths and woolly mammoths and saber-toothed tiger or those kinds of animals were walking around in Siberia and the Arctic circle because it was very warm, and there was lush green forest because it was so warm, and there was rain, right? So it was continuing to warm, and there is one big spike here called the Paleocene-Eocene thermal maximum, which is a good proxy for how quick warmings can happen. But it turns out that this warming of almost 5 degrees happened actually over several thousand years. It's different than what we are doing now, because now we are warming the temperature in just a couple of 100 years. So the response of the ecosystem, the circulation, everything changes depending on how fast things change. Okay, so for several reasons that we don't necessarily get into in this course. One of the reasons I will mention a little bit later on, that has to do with movement of continents and building of new mountains. Okay, the temperature began to cool down, and we'll see later on that all the temperature changes have been associated with carbon dioxide changes. Okay, so again, multiple time scales. You can see that there are faster time scale changes and then slower time scale changes, and so on and so forth. The main message is climate has changed and has been much, much warmer than now. Why should we worry? Let's say if grandmother asks, why should I worry if dinosaurs were living in a much warmer climate? Because we were not around then. We don't know whether we can survive in those kinds of temperatures. And we will see the change that happened in the last 12,000 years since the last ice age ended. And we will see that even small changes in temperature have had big impacts on civilizations that existed at the time. And global warming at present has created lots of conflicts, armed conflicts, civil conflicts, and so on and so forth. So survival is not guaranteed. We have evolved in the last 12,000 years as modern human beings, and we will see that this may have had something to do with the relative stability of the temperature. And now we suddenly start accelerating the change. What does it mean for us, our own survival? Okay, so climate has always changed for various causes. We will see what are some of the causes. I already mentioned two of them, the orbital changes and plate movements or tectonic changes, mountain building, etc. Let me stop this here and then go to the next slide in the next podcast and make a few more points about how climate changes and how the timescales of climate change also vary